Listed are the earnings in millions of dollars of the celebrities with the 10 highest incomes in a recent year. Find the mean, mid-range, median, and mode of the data set. Round to one decimal place as needed. Mean, symbolized by x bar, equals the sum of x divided by n. So to calculate the sum of x, we need to add those data values. We get 1,598. N is the number of data values in our data set. There are 10. Divide by 10. So the mean equals 159.8. That translates into $159.8 million. Mid-range. Mid-range is minimum value plus maximum value divided by 2. If the data was sorted, it would be 67 plus 332 divided by 2. We get 199.5. In other words, $199.5 million. For median, we need to sort the data from lowest to highest. Since there are an even number of values in our data set, we need to take the average of the middle two. If we divide the data set in half, where there's 5 values to the left representing 50% of the data, and 5 values to the right representing 50% of the data, the median will be directly in between those two numbers. If the data set had an odd number of values, we would simply take the middle number. So the median is 90 plus 100 divided by 2, which is 95. $95 million. The mode is the data value that occurs the most often. In this case, no data value is repeated, so there is no mode. Find the mean of the data summarized in the given frequency distribution. Round to the nearest tenth as needed. Compare the computed mean to the actual mean of 46.8 miles per hour. In a grouped frequency distribution, we need to use the midpoints. So the midpoints, x. The first class midpoint is directly in between 42 and 45. 43.5. The next, 47.5. Then 51.5. Then 55.5. Then 59.5. We also need F, and that's simply just copying from the data that we already have. The formula we use for mean is the sum of F times X divided by the sum of F. So we also need that value as well. So the sum of F times X, I will not write the entire thing out, but I'll show you how I find it. It would be 25 times 43.5 plus, then you do the next class, 14 times 47.5 plus ... we would do the rest of the classes. Now let me just show the last one. 2 times 59.5 divided by the sum of f, which is 51. So the mean, after calculating that, the numerator, we get 2,402.5. That's the sum of f times x over 51. So the computed mean is 47.1. Now to compare that to the actual mean, what we do is we find the difference first. So the actual mean and the computed mean differ only by 0.3. Now let's think, what fraction of the actual mean is that? Or what percentage? So we can do 0.3 divided by 46.8 to get a decimal, multiply that by 100 to get a percentage. We get 0.64%. So the difference between the computed mean and the actual mean is less than 5% of the actual mean. If it was more than 5%, we would say that there is a significant difference. When it's less than 5%, we say the difference is not significant. Listed below are the lengths of time in years it took for a random sample of college students to earn a bachelor's degree. Find the range, variance, and standard deviation for the data set, for the set of data. Round to 2 decimal places as needed. Based on these results, is it unusual for someone to earn a bachelor's degree in 12 years? Okay, so the range is fairly simple. It's maximum value minus minimum value. The range then is 15 minus 4, or 11. So range is 11 years. The formula I like to use for variance, which is s squared, is n times the sum of x squared minus the sum of x squared over n times n minus 1. And then standard deviation is simply the square root of the variance. So s is the symbol for sample standard deviation, is n times the sum of x squared minus the sum of x squared divided by n times n minus 1. Okay, so we'll refer to these two formulas. So what we need are n, sum of x squared, and sum of x. So we need these values. We know what n is. N is the number of elements in our data set. There are 20 values in our data set. The sum of x squared, what we're doing here is we're going to square each data value and then add them together. So we would get something like this: 4 squared plus 4 squared plus ... And then I'll show the last two: 13 squared plus 15 squared. So we square each item and we add them together. We get 1078.5. The sum of x is just the sum of the data values. In this case, we get 130. So we have all the pieces that we need for our formula. So let's do variance first. S squared is n, so 20, times the sum of x squared, 1078.5, minus the sum of x, which is 130, quantity squared, divided by n, which is 20, times n minus 1, which is 19. In this case, in our numerator, we get 4,670. In our denominator, we get 380. So the variance, s squared, is approximately 12.29. This is not in years, so we're not going to write down the measurement in this case. The standard deviation will be in years. So s is the square root of 20 times 1078.5 minus 130 quantity squared over 20 times 19. So s is the square root of 4,670 over 380. So s is approximately 3.51 years. Standard deviation is in the same unit as the original data. Okay, now the question asks, is 12 years unusual? So for usual, to find the minimum usual value, we calculate that by determining x bar minus 2 times standard deviation. So we do need to find the mean. The sample mean is add the numbers, divide by 20. You get 6.5. So 6.5 minus 2 times 3.51, or negative 0.52. Our maximum usual value is x bar plus 2s. So 6.5 plus 2 times 3.51. In this case, we get 13.52. So 12 years is in the range of usual. So 12 years is not unusual.